We continue to discuss examples or solve problems on continuity equation, and now we consider a simple example of flow that is incompressible. And conditions for incompressible flow, let us see how do we ensure that. That means that there should be no variation in density when or in compressibility when the fluid flow is moving or is taking place. We consider a simple example. Consider a steady velocity field given by V with the components u, v, w, in which the values of u, v and w, all three are non-zero. They are given in the respective where I, j, k are unit vector in x, y, z directions respectively, and a, b, c are some constants. Under what conditions this flow field is incompressible? This flow field will be incompressible if the continuity equation is satisfied, if the law of conservation of mass is maintained, is retained. And therefore, all we have to do is that we consider a steady flow. So we make an assumption that the flow is steady and the flow is incompressible, that is no variation with respect to rho, if rho is the density of the fluid under consideration. The equation, the continuity equation in rectangular form will be du by dx plus dv by dy plus dw by dz is equal to 0. And from the given component that have been given to us, when we calculate and substitute them here, we obtain 2axy is equal to 2bxy is equal to 0. And further simplification of this gives us that a must be equal to 0. So, simple condition for this equation that is given to us, the incompressibility of this fluid flow will be maintained if the constant a is equal to minus b. That will ensure that the fluid flow as given is incompressible.